What I want you to do is I want you to watch this video, and then I want you to record notes onto this Google Sheets. You're going to click the link and make a copy, and then you're going to edit into the squares. And then when you drag the triangles into the right spots, make sure you click on them, let up, and then click again to drag them. Anyway, let's go and get started. All right, let's start by filling out this chart here. A median. A median is a line segment that goes from the vertex of a triangle to the midpoint of the opposite side. So if I got this cut in half and I draw a line from the vertex, that's a median. You'll notice that no matter what I do, the median is always going to be inside the triangle. That's important. So when lines in a triangle meet, or any two or more lines meet, we call it a point of concurrency. When three medians meet in a triangle, it's called a centroid. So here's a diagram where I've got three medians, midpoints, and then connect to the opposite vertex, and they'll always connect to the same point in the middle. That's called the centroid. And you'll notice that no matter how I adjust the triangle from a right triangle, obtuse, to an acute, the centroid's always inside the triangle. You'll also notice that the segments are divided into 2 to 1. The long part of the segment, median, is twice as big as the short part. Now let's go ahead and try to draw a picture here. Don't drive yourself too crazy. Draw a midpoint and then connect it to the opposite vertex, and then do it again. And once you've got two of them, well, now make sure it goes through that midpoint where they intersect. Anyway, you remember when we moved the triangle around, whether it was acute, obtuse, or a right triangle, the centroid was always inside the triangle. Couple things to remember. The centroid divides the median into a long part and a short part. The long part is always twice as big as the short part. The short part is always half as big as the long part. And then the other thing to remember about a centroid is that it's a center of gravity. A lot of times it's used in architecture. It's a balancing point. All right, now angle bisector. That's just what it sounds like. An angle bisector is a line that divides the vertex into two equal angles. When you've got more than one angle bisector in a triangle, they meet at a point called the incenter. So anyway, an angle bisector, like we said, it just cuts the angle in half, and then it goes wherever it goes. So when you're doing an angle bisector, you focus on the angle, cut it in half, and then just draw a straight line. All right. So now, let's take a look at what happens when we have more than one angle bisector. If I've got more than one angle bisector, you'll notice that no matter what kind of triangle it is, acute or right or obtuse, the incenter, the point where they meet, is always inside. So that's something we have to remember. Now the other thing is that if I take this and if I draw a circle here, you'll notice that the incenter is the center of a circle that touches each side of the triangle once. It's called inscribed. And because it's a circle, each one of these lines, perpendicular lines that go from the center to the side of the circle, they're a distance, and you'll notice that they're all going to be the same. So a incenter is equidistant to the sides of a triangle. All right, so let's write some of this down in your graphic organizer. So remember, when you're drawing your picture, don't get too whacked about it. Draw an angle, cut it in half, draw an angle, cut it in half, and then when you do the third one, we'll just make sure that it goes through that point where they intersected, and it may not be perfectly for the other one. Remember again, the inside, inside, inside. An incenter is always inside the triangle, and you can draw a quick circle if you want on the inside. Incenter is the center of a circle. We need to remember that. It's inscribed in the triangle, and consequently the incenter is equidistant to each side in a triangle. Okay, so that's a centroid and an incenter. Let's take a look at the next ones. A perpendicular bisector, again, just like what it sounds. It starts at the midpoint of a side, and then it cuts the side in half, and it also creates a right angle, a perpendicular angle. Perpendicular bisectors are all about the side. So here, you'll notice I don't even need a triangle. To draw a perpendicular bisector, all I need is a line segment. It's got to be cut in half. And the second that I create another line that is perpendicular to it, I've created a perpendicular bisector. Now, when I put more than one perpendicular bisector in a triangle, they meet at a point called a circumcenter. The circumcenter, you'll notice now I've got a 90-degree triangle. The circumcenter ends up being at the midpoint of the triangle when it's a 90. If it's acute, it's going to be inside, and if it's obtuse, it'll be outside. If I make a circle on the outside, you'll notice that the circumcenter is the center of a circle that circumscribes. It goes around the circle. And then consequently, the circumcenter is equidistant to every vertex. Because it touches the corners of the circle, those are going to be radii, so each one of those distances are going to be the same. So what we've got to do now is transfer some of the information onto our paper. The perpendicular bisectors meet at a point called a circumcenter. If you're drawing this, then draw a midpoint, and you should draw hash marks, I didn't, and then try to do a perpendicular line that goes straight from it. Do that twice, and then again, like I said, for the third one, just make the line go through the points of intersection, and hopefully it'll be close to perpendicular. So in an acute triangle, it's inside, an obtuse triangle, it's outside, and on a right triangle, a circumcenter is on the midpoint of the hypotenuse. And a couple things to remember about a center. It's the center of a triangle that goes around the triangle. That's the circumcenter. And then consequently, the circumcenter is equidistant to each vertex. You need to remember that also. And then if you want to, you might want to go back to your drawing and then draw a circle around the outside. And if you want to draw the radii and show that they're the same length, you can do that too. This is all information you're going to have to be able to come up with. All right, so the last one, it's an altitude. An altitude starts at a vertex and then it makes a right angle at the opposite side in a triangle. I'm sure you've heard the word altitude when we talk about the height. When altitudes meet, they create an orthocenter. So remember, vertex, okay, altitude is the height of a triangle, goes from a vertex and it creates a right angle. Now what's interesting about an altitude is it sometimes is outside the triangle. So if it's obtuse, it's going to be outside. So here we've got three of them. You notice how the orthocenter is on the inside while the triangle is acute. When I make it a right triangle, you'll notice that the orthocenter is at the corner where the right angle is, and if I make it obtuse, it goes outside the triangle. So it's acute, it's inside, and when it's a right triangle, it's on the corner of the vertex, and when it's obtuse, it goes outside the triangle. So let's fill in this information. Again, try to do a sketch best you can, and then let's fill in the information. Acute, it's inside, obtuse, it's outside, and in a right triangle, it's on the triangle at the vertex of the 90-degree angle. And then as far as orthocenters go, there's nothing particularly interesting about them except the fact that they meet at the corner of the right angle. All right, so I hope that helped. Let's look at the back.